Here's precalc lecture video for lesson 115. It's the remainder theorem. So basically what the remainder theorem says is that when you divide a polynomial using, well, the easiest way to do it would be using synthetic division, your remainder that you get is actually the same exact number that you would get if you were to plug the divisor in and evaluate the polynomial. Or in other words, I can tell by looking at this synthetic division problem right here, I can tell that if I plugged -1 in everywhere I see an x, I would end up with -3. So why would we care about this? Sometimes, I mean, in this case, it's easy just to plug -1 in here. It's probably faster than doing synthetic division. But sometimes with a really big polynomial, it's faster if you want to evaluate it at a certain x value. It's faster to do the synthetic division on it. I'm going to plug the -1 in here just to show you. -1 cubed would be -1. 4 times -1 would be -4. Plus 2, well, there's -5 plus 2. See how that makes -3? So that will work every time. Okay, that's the remainder theorem, and it's just a handy way of evaluating something quickly. So, and they go through, I guess they're going through and showing you. I'm going to go through, probably just show you using the problem number 6. But they go through and they basically develop this formula right here that says your original polynomial is equal to the quotient of the polynomial times the divisor plus the remainder. And so we'll show you. I'll show you how that all works. When you plug in whatever your divisor is, when you plug in, it always zeroes out one of these terms, and it just ends up being that the polynomial evaluated at a certain point is always going to equal whatever the remainder is when you do the synthetic division on it. So I'm going to do it with number 6 though. So here's number 6. I kind of already did some of the work on number 6 to save time. So I'm supposed to use this polynomial equation and a divisor of x plus 2 to do a specific development of the remainder theorem by showing the remainder equals f of -2. Well, I already kind of cheated and just checked it, but there's a way that they want us to show this. So what I did is I just grabbed this and did my synthetic division. You take the opposite right here, so it says x plus 2, so I'm going to divide by -2. Then I grabbed the coefficients, and you have to put zeros in if there's the x's have to be in descending order, and if there's a term missing, you have to put a 0 in, but these are fine. Okay, so then I did my synthetic division. I found out my remainder is -50. So then, just to check and make sure that this thing works, I plugged in -2 into the original function. So 3 times -2 cubed turned out to be -24, and 9 times -2 squared, see, I'm just plugging it in, was -36, and 3 times -2 made 6, and then add the 4, and so I proved it to myself, but I'm supposed to make a development of the theorem. So what I'm going to do is I'm going to take the original function. Can we see when I write down here? 3x cubed minus 9x squared minus 3x plus 4. Well, we know that we can write that in factored form, because we remember, or I hope we remember this, this started out as a cubic, and then remember these numbers are the coefficients of, you can go down 1 degree, so now we're going to have a quadratic. These numbers can be the coefficient. Remember, we go x squared and x, like that. So we're going to say 3x squared minus 15x plus 27 times, and remember we can write it as, when we're doing our factoring, we write it as that times, this will give us x plus 2. And then just that 50, usually we'll just say plus 50 over x plus 2, but we're just saying there's that leftover is 50. Okay. Okay, so we have an equality. This is equal to this. And then, so now I'm going to plug in negative, what was our divisor? Negative 2. I'm going to plug that in here. Now, I don't really want to do it all over again for you. I already did kind of plug it in. You can see, we know that it's negative 50. Okay, so this, whatever this turns out to be, when I plug the negative 2 in right here, what's going to happen to this term? What's negative 2 plus 2? That's going to make a 0, isn't it? So it's going to zero that whole thing out. I'll go ahead, since I'm doing a development, I'll go ahead and get some value for this. This would be, let's see, I'm plugging negative 2 in. So negative 2 squared would be 4 times 3, that would be 12. Right, I plugged a negative 2 in there. So that's not 0. But when I plug the negative 2 in here, isn't it 0? So, well, what is that? That would be 32 plus 27. Well, that would be 59. So that's 59 times 0 minus 50. So they kind of want you to follow this procedure. Well, 59 times 0 is 0. So then I just have negative 50 is equal to negative 50. And they'll probably have you do that a few times. They show that on the opposite page, on page 636 in an example. But anyway, that's your lesson 115 lecture video.